Knowing how to find distances between points turns out to be one of the most useful ways we have of talking about the geometry of points by looking at just their coordinates without looking at the actual plotting of the points on a graph. One thing we might wonder about points is whether or not they are collinear. If we have 3 or more points, we say they're collinear if they lie on the same line. So in this figure, points A, B, and C are collinear because they lie on line L, which we could give lots of names, right? Use any 2 of those points with a line symbol over them, and that would be a name of that line. But D does not lie on that line. It's not collinear with any pair of those points. So we could draw a line AD, but that wouldn't go through B or C. We could draw a line BD, but that wouldn't go through A or C. We could draw a line DC, but that wouldn't go through A or B. We only talk about sets of 3 or more points being collinear or not, since if we have any 2 points, we can just draw a line through them like we just did in the example. So 3 points being collinear is a special fact about them. 2 points, of course they're collinear, just draw the line through those 2 points. If we have 3 points, and we label them laid out like in the example, with B being the one that's between A and C. So the point B lies on the segment AC. Then we have the following property of the Euclidean plane. If we take the 2 smaller pieces and add them together, they add up to the whole segment. And when we say that this is a postulate, or a property of the Euclidean plane, we mean that that's one of the things that we're talking about when we talk about distance in a plane. It's always going to have that property because that's part of what we mean by distance. Now, we can use this fact along with the distance formula to take 3 points and decide, are they collinear? And in this example, I'm going to start by plotting my 3 points, and then we can just look at them. But our ultimate goal is to do this without plotting the points, partially because very often we have points with unpleasant coordinates. Notice that this point is already going to be kind of unpleasant to plot, since it has a fractional coordinate. When we're planning our graph, we might want to make that into a mixed number. This is 2 1/3. You can make that into a mixed number on your calculator if you like, or by hand, whichever you prefer. So let's see. Our x values, it looks like they're going to go from -2 to 4. And then our y values are going to go from 1 up to 5. So a set of axes like this should work for us. Our points are A at -2, 5, B at 4, 1, and C at 2, 2 1/3. Are these collinear? Well, if I draw the line segment connecting A and B, C looks like it's real close to that line segment. It's really hard to say. C is a little bit off the line segment. Did that happen because C really isn't on that line, or because I'm bad at drawing? One of the major reasons that we want to have a way by calculation to determine whether these points are collinear is that determining it by careful drawing is actually pretty hard. So let's see. Let's find the distances between these pairs of points using the distance formula. The distance formula, remember, we take the difference in the x's. So for AB, that'll be -2 minus 4, and square it. We take the difference in the y's. So for AB, that'll be 5 minus 1, and square it. And then we take the square root. So we'll use the calculator for this. We'll have -2 minus 4 squared plus 5 minus 1 squared. So this will be square root 52. And since we're planning on doing some arithmetic with that later, we might want that as a simplified radical. So I'm going to just put that in. So square root 52 is the same as 2 root 13. We might also want a decimal approximation. So that's about 7.21. Okay, we'll do the same thing for BC. So we take the difference in the x's, that'll be 4 minus 2, and square it. The difference in the y's, that'll be 1 minus 7/3, and square it. And then we take the square root. So let's see. 4 minus 2, and square it, plus 1 minus 7/3, and square it. That's 52/9. Take the square root. So let's see, our denominator, square root of 9 is 3. Our numerator, well, we already know that root 52 simplifies to 2 root 13. So we could write this as 2/3 times root 13, or as a decimal approximation, this is about 2.40. Okay, what about AC? Same thing. Difference in the x's, so -2 minus 2 squared, plus difference in the y's, so 5 minus 7/3 squared. Take the square root. So -2 minus 2 squared plus 5 minus 7/3 squared gives us 208/9. That doesn't look like much fun. But denominator, we've just got 3. Root 208, that simplifies to 4 root 13. So that's 4/3 root 13. That's about 4.81. So, those are the distances. Are these collinear? Well, we see that the longest distance is AB, which we already knew from the picture. But if we hadn't drawn the picture, we would need to notice that. And so we check, is 2/3 root 13 plus 4/3 root 13 equal to 2 root 13? It sure is. So, are the points collinear? We see that, yes, in fact, the points are collinear because, let's see, in this case, the long segment was AB. And the way that we actually added them was BC plus AC gives us AB. And why did that point end up a little bit off the line segment when I drew it? Because I'm bad at drawing. Maybe I drew that a little bit below where 2 1/3 actually is. Those 3 points are in fact collinear.